Hey everybody, I'm going to do another class on champagne. And this one is about where did the bubbles come from? Now that seems fairly obvious if you know about sparkling wine. It comes from the fermentation, of course. The yeast eats the sugar in the grape juice, and one of the byproducts is CO2. Voila, bubbles. Yes, that is 100% true, but the bubbles in our glass, what happens? Why does it bubble? What's going on in our glass? So this will be a short little video, but I just find this so interesting. And this is, of course, true for other carbonated beverages, but I think that the most elegant and beautiful way that we see it is in champagnes or high quality sparkling wines. And there's more happening here than just bubbles in our glass. Like, why do we like this? And it's because it gives us pleasure, right? It gives us multi-sensory pleasure, and it's doing something that other wines can't and don't do. And I love sparkling wine for that reason, and I want to share it with you. So, why is a glass of sparkling anything sparkling? So what's happening is that it's called Henry's Law, and it's the desire to create equilibrium. Starting off great here. Um, and what's happening is that the dissolved CO2, so the carbon dioxide that's dissolved into the liquid, is trying to create equilibrium with the outside pressure, and in this case, the air pressure above the surface of the liquid. It takes, on average, the escaping of 11 million bubbles in order for a glass to reach equilibrium for one flute, which is just astonishing. Most of the CO2, interestingly enough, though, is actually escaping right from the surface, and we're not seeing it. So most of it is just coming from that meeting point of the surface of the liquid and escaping into the atmosphere. The rest of it is coming through the bubbles. Now, I'm going to pour a little bit more because I want some, but also because I want to show you. So a ton is escaping right now. We can see that, but we're talking like 80% actually just escaped. So that's pretty cool in and of itself. Now, why is it bubbling? Bubbles need somewhere to start. You need something to kick them off. If there was no dust, microparticles, fissures on the microscopic level on the inside of this glass, there would be no bubbling. There would be no activity at all. So we need it's called a bubble nucleation site. It's a bubble nursery. So it could be like a little fiber from your polishing rag or whatever detritus in the air. And that is what's causing a bubble train. Now you notice when you look at a glass of sparkling wine, particularly one with fine bubbles, that they're not just random. You can see that they are spouting from one or several different areas, but you could follow a bubble train down to its nucleation site. So that's pretty cool. And what happens is they pick up more CO2 as they rise. And that's what makes them rise increasingly more quickly because they start to overcome the buoyancy of the liquid that they're in, right? So their buoyancy overcomes the liquid. Now, the ascending bubbles, if you really observe them, you notice that they're not necessarily going up straight. They're going in a spiral, a radiating pattern. And what that helps to do is to aromatize the volatile compounds that are the smell and the fragrance of the wine. So this is far more active than a still wine. Now, again, common sense, this makes sense, right? But why do we smell wine? We smell wine because there's molecules of it in the surface of the glass. This is why we swirl wine. Basically, you can think of sparkling wines as being self-swirling. They're going to create so much more activity above the surface here, and therefore so much more to smell. It shoots it right up your snoot. Oftentimes you're like, "Oof, you got CO2 up my nose." Um, This is also why I preach using an all-purpose glass for a high-quality sparkling wine, because otherwise you're missing out on all of that complexity. You're just really selling yourself short because the wine has so much to offer you. Um, and I don't know, you can kind of poo-poo this concept, but I said earlier, what are the bubbles giving us? And they're giving us pleasure. And I don't think that that should be minimized. We have the sound, if you're able to, if you're of sound hearing. Um, it's a lovely sound that we don't get from every wine. We get this little snap, crackle, and pop that's really lovely. We get this fizzing. The bubbles burst, so they come to the surface, and then the top cap of them becomes weak enough that they, again, another equalization, um, and the pressure above and below. Um, the bubbles also, when we stick our snoot in there, they burst enough that they actually hit the pain receptors in our nose, which is why we go like, you know, well, maybe not all of us quite like that, but that's what's happening there. It's actually a little bit of pain, a little pleasure pain. We all know what that is. So because the CO2 is a powerful irritant in the inside of your nose. Um, and they are going to, and again, in that process, they're carrying the higher concentration of the flavor compounds. And another feeling here is the mousse on your tongue, those fine bubbles. Um, they stimulate, again, the nerves on your tongue, and we can feel it similar to your nose. And we feel that mousse. And so that's just a different experience. And then also, just if you're able to see bubbles, they just happen to be really beautiful. Um, it's sort of a pleasure to watch them do their thing that's kind of mesmerizing. Um, what did I also want to finish here? Um, if we left our glass alone, like let's say that we poured it, we forgot about it, and we walked away, proteins would build up on the surface here, and this would give the bubbles a longer life. They actually would not have as much of an ability to break the surface, but what can break the surface would be fats. So that's why like lipstick, which has high fat concentration, or high fatty foods, which we do tend to consume with sparkling wine and champagne, that makes the bubbles burst faster and it makes the wine go flatter faster. And if we just continue to leave this alone, the bubbles are going to organize themselves in this spiral sort of galaxy pattern. And it's dictated by the shape of the glass and by that bubble nucleation site. So after, the initial crazy activity of pouring, you'll start to notice really distinctive patterns when you just leave it to itself. Um, and then that's in your glass. Bubbles in the bottle. I talked about this in the last video. Why, obviously, a younger bottle of champagne or sparkling wine is going to be so much more active because all of that CO2 is dissolved in the liquid. You pop the bottle, it's got all of that CO2. If you age a bottle of wine, a bottle of champagne, there will be a loss of that CO2, and that's why an older bottle of champagne, the bubbles will be finer, smaller, less mousse, less activity, but a more developed wine. So I don't know, give your glass of sparkling or champagne another look next time and give it a little bit more credit for all the things that it's doing because it is a unique product in the wine world. It's unlike other things. And that's what makes it special. So cheers again, and I'll see you for next class. Thanks.